to another one of these videos. Today we're going to be covering horizontal, and we'll just go ahead and get into it real quick. The horizontal rule is that no two minds can touch horizontally. And there actually is a version of this variant in Minesweeper Variants 2 that, if you've seen any of my videos on that, you might recall. It's basically just the inverse, where every mind must have one horizontally adjacent. So, yeah. Just be sure to remember that that is not what this one is, so you don't get confused or anything. We'll go ahead and get into a puzzle for it real quick. So, and this is actually something I've been thinking I should probably re-explain just because it's been a while for a while. So, I'll real quick talk about what the difference of minds logic is. So or I guess difference of area logic is for some stuff like this. So for instance, with this set of clues, we know neither of these can be minds. And the reason for that is that from this one clue, we know there must be at least one mind in this region, right? Oh, exactly one mind in this region, rather, also. Then that tells us for this one, there must be exactly one mind in those two squares, so neither of these down here can be minds. Similarly, we can see that implies none of those are minds. And the only other real, version of this style of rule is if there's a different number, for example 2 versus 3, we know regardless there will be some number we can just say, I guess, x minds in here, right? So then we know the amount of minds up here will be 3 minus x, and the amount of minds down here will be 2 minus x, right? There we go. Okay. And something we can note is that we can never have a negative number of minds around, or rather in an area. So we know that at lowest 2 minus x will be 0. That implies that this will have at least one mind. And we can also see that the difference of number of minds between this is 1 versus 0, right? So that tells us there's at least one mind up there. And that kind of logic can be used quite a lot, especially in normal Minesweeper. But I figured I've been saying that a lot, especially in recent videos, and I thought it'd be good to explain it. Anyway, we can also go ahead and finish off that 0 clue from kind of a similar idea. We know that both of these 1 clues have minds in each of these regions. That finishes off the 2 clues, so there cannot be a mind down there. There we are, and okay. Something else that's kind of unique about horizontal specifically is we know that there can only be at most one mind down here. If there were 2, then it would break horizontal rules, right? We also know from the difference of areas, logic we talked about earlier, that there must be at least one mind here. So that tells us there's exactly one mind there, exactly no minds there. There we are. Okay. And now, I guess the next thing to consider would probably, will be what to do about this 3, right? So we know there's going to be one mind there. We also know there's at most one mind there. Then that tells us there's a mind here, and that both these regions have just one mind, right? Let's put a mind there, get rid of its horizontal neighbor, and alright. I guess the next thing that we can kind of consider is what happens if we put a mind here, for instance, right? That finishes off the 2, but then this doesn't actually leave enough cells in the 4 to fit around the 4 to fit all of its minds, right? Because we can only get at maximum 3. So we can mark this one as a non-mind. We can also then notice that there will be one mind here, and then all of these regions still remain the same, so we know there's a mind over there as well. We can also see that there will be one mind here from the 2, so there cannot be a mind over here just from this 1. And then, lastly, and I guess, I don't know why I got rid of these, we can put them back in. Since we already know this is the case, this 2's mind must be over there, then we can just finish off some of these clues, mark our horizontal neighbor. That's just something you generally always do when you put a mind in this variance, is you just mark the one next to it. And you can just fill in all of this stuff as well. Just finishing off clues. And, okay, cool. We don't really need these markings anymore. We now know from this 3 that there will be at most one mind up there, so then we get 1, 2, and a third one over there. That tells us there's no mind there for the 2. We can also finish off this 4, mark off both of these. And lastly, we can see that there is one mind here, one remaining mind with our global mind count, so that mind must be there. No mind there for horizontal. There we are. Alright, so that's just kind of what horizontal puzzles look like. We'll go ahead and go into a more difficult one real quick. So here we go, and okay, first of all, we can get both of these just through normal Minesweeper logic. We can also now see that since there can be at most 2 down here, once again having 3 for the same reason as we talked about within the 2 case earlier, breaks the horizontal rules. So we know there's at most 2 down there. That tells us there's at least 1 up here, but there can be at maximum 1. So we know there's exactly 2 here, 1 there, so there's no mind up there. Mark both of their neighbors and finish off this clue as well. And then we can also see that there will be at most one mine down there, so there must be a mine up here, one mine down there, no mine over there for the 2, right? Yeah. Okay. And I guess something else we can now consider is we know there can be at most one mine over here, and since these 2 3s, I guess, are the same number, we know that the fact that there's exactly one mine up there tells us there's exactly one mine down here. Ultimately, that just means there cannot be a mine over here, because that would make it so there had to be 2 down there. Anyway, we can now just finish off a lot of clues. It seems like this 3 is also finished, and okay. There we are. And now we can see we only have one mine left, but that mine must be in both of these 3 regions. The only square they overlap is here, so there we are. That has completed the puzzle. And now we'll go ahead and go on into some combination variants, or versions of this, I guess. We can first start with mini cross. Alright. Okay, so first of all, that clue is just finished. We can also mark its horizontal neighbor, and okay. Now we can, I guess, kind of consider maybe some squares that might run into issues or something like that. Okay, one thing we can notice is if we put a mine here, there cannot be mines in either of these positions, right? And that finishes off this 2 as well, which then will finish off that 2, but we can see the 3 doesn't have enough mines around it. So we know there cannot be a mine there, and there we are. Okay. I suppose it might be worthwhile to just kind of look through some of the combinations for, like, maybe this 3, for instance, to see if there are any squares that are usually in common. So first of all, we can just consider this case, where the 2 mines with 3 are over there. Then we can just get all of these deductions just kind of through finishing off clues. There we are. Okay. Next one to consider is this grouping right here. Then we get all of this. Cool. And the last one to consider is this group right here, which then gives us no mine there, no mine there, no mine up there, mine up here, and then, yep. So we can see that this mine up here must always be filled in, just because this combination of 3 cannot happen ever. So there we are. We can also mark off both of those. Get rid of our pencil marks real quick. And we can see that one is finished, as is this one, and now this one, and this 0, and all of those 1s are also done. So is this 3, and thereby those 2s. We can mark that, just because horizontal. Finish off that 2, and we can see we only have 1 mine left, and it must be one of these 2 squares, so none of these are mines. And this one is now finished, finishing off this one as well. So there we go. We'll next go ahead and move on to horizontal knights. Just get into that real quick. First of all, this 0 clue is just finished, and now we can go ahead and kind of see if there are any patterns or anything we can glean. One thing that I'm kind of noticing here is this 2 is pretty restricted with its options, so we're just going to go ahead and go in and try out all 3 of its cases. See if there are any common like squares that we can find. Oh, whoops. This one should not be a mine in this case. There we are. Okay, unfortunately it doesn't look like this one's going to give us much else beyond just this. The next one we can consider is the group of mines with those filled in. Then we get no mines either of those positions, no mine over there. And does this give us anything else? Not necessarily either. Does it? Does not really appear so. Okay. I guess we can now see if this blue case will lead to anything particularly exciting. This might just not be the correct way to go with all of this, to be honest. That's more so what it's looking like it might be. So one thing we can notice in that case, there must be a mine right here as well, which then finishes off this one, giving us this as well. And importantly, we can notice that this one is just never a mine, so there we are. Okay, now we can finish off that 0 and this 0 as well. We'll just go ahead and get rid of some of our marks that are now obsolete. Alright, unfortunately none of these really seem to rule off a case or anything, but that's okay. One thing that we can do from here is just kind of keep working now through the case analysis, given that we have more information. Although, I guess this one actually now is more restricted in some of the other cases. Like, for instance, we know the yellow case, there must also be a mine here, which then tells us that this yellow case also does not have a mine there. And this one's also finished, so we can actually just mark off both of those things real quick. Alright. So now we can see in both the yellow and blue case there will be no mine here since this one is already completed, and then that gives us, alright, in both cases, yellow and blue, that gives us the remaining mines around this 3. So here we can just go mark those in real quick and also mark off all of these squares as well as being non-mines from horizontal. And okay, next this also finishes off this one clue in yellow and blue. And okay, where does this all really leave us? That also, I guess, just in the context of yellow and blue, finishes off this 2 clue, which is interesting. I'm surprised at how many deductions we're getting from these 2 specifically, that red just really doesn't have much else. Feels definitely a little strange, but that's okay. And I guess we can now also see that... Okay, so we can see yellow, actually yellow, yeah, works fine, as does blue. Okay, but they do actually have a difference here. Blue has no mine there, whereas yellow does. Correct? Yes. Yeah. Okay. So that's something, I guess. Yeah, I'm not sure if this is really going to lead to a lot. Something that might be interesting is considering if there can ever just be a mine up here specifically. I think that's what I'm going to look at now. Hopefully there wasn't some deduction in there that I just missed, but if there was, that's okay. So we're just going to assume that there is a mine up here. I suspect this will just not work, given that none of our previous cases guaranteed this, but it's hard to tell just from the outset. Also, there's a mine over there. And that will finish off this 3 clue, so we can go ahead and mark in all of those as non-mines as well. And, alright, we can also mark this one's a non-mine because our 1's finished. What else do we get? This also finishes off this 2, so we can mark that as well. And, okay. No, this doesn't really lead to any contradictions. One thing we can notice is, as showed earlier, the red case is the only one where this could happen. We can see we have the same initial assumption as in the red case. Kind of baked into this. That's okay. I guess the other thing I'll then consider is if instead this one down here is a mine and see if that changes anything really. Then we know this one cannot be a mine from red. Correct? Yeah. Okay. So then from here, what else do we get really? Okay, one thing we can notice is that there will be 1 red mine within this square and this square for the 1, right? So then it tells us that one of the squares next to them will not be a mine. Similarly, we can see from this 3, well, okay, actually, never mind. That 3 isn't as restricted as I thought, which is unfortunate. That tells us that at most one of those 2 squares is a mine. Unfortunately, it does look like there are enough other spots open where the 3 doesn't even have to really consider that. I guess one thing we can also notice is that in the yellow case, this 3 only has 1 left. Yeah. I don't think that tells us a lot on its own, though. Okay. Maybe this angle wasn't the correct one to look at. Although, I guess we can see this 3 only has 1 possible, non-mine left in it. Correct? Yeah. Okay. We can also... Maybe it's important to put that in as well. I didn't realize that this 1 was also finished in this case. What else does that tell us then? We know there must be a mine on one of those 2 positions. Is there anything else to share with that? Not entirely, but... Okay. Oh, that does actually finish off this 3. Oh, that's actually pretty relevant. We can mark in all of these then. Get rid of both of these cells. And you can see this leads us to anything now. I'm not really sure, to be honest, on its own, if this gives us a lot here. right? Because, yeah, we still have this 1 in the same position as before, this 2 in the same kind of position as before. Oh, wait, yeah, I forgot for this 3, I also should mark this 1 in. And, okay, does this give us anything now? Yeah, it finishes off this 1. Okay, there we go, finally. We can see this cell is just never a mine. There we are, and hopefully this 3 just disallows one of our cases. Yeah, we can see that it means the yellow case must be accurate, so we can just mark in all of those, and from here we can work backwards, basically, to get the rest of our deductions, I believe. Correct? Yeah, because that one can only have 1 position, then that one can only have 1 position. That also gives us both of those. And then from here, this 3 is finished. Okay. And this 1 is also finished, which finishes off this 2. No horizontal neighbor. This 3 is done, and now we only have 1 cell left, 1 mine left. There we go. Cool. That definitely took a bit, but that's okay. And even though I have finished all the horizontal longest walls, I guess I could do one again. Maybe... Yeah, I guess I'll do an easier one. This one will be larger, but that's okay. Since it's not an exclamation mark, each of the clues will give more information. That's all good, though. We can first of all finish off all of these zeros, and this 0 as well. This 1 clue is also finished. We can mark horizontal neighbor. We also would just get that from the 1 clue normally as well. We can also mark in that. One thing we can kind of notice for this 2 clue, we know that there are only a few possibilities, right, of where the 2 size region can be. But however, we can already see that both the yellow and blue case aren't allowed. The yellow one just from this 1 clue would overload it, and the blue one from horizontal. So that actually tells us the mines are exactly here. This 2 also cannot extend any further. Both of these need their neighbors marked. This 2 is just finished, as is that one as well. We can see for a similar reason as with this 2, these are the only positions where mines can be for this 2 right here. This 2 is now finished, so there we are. Okay. And now we can kind of similarly see, and this is just a general idea for like clues in longest wall and even just normal wall in general with horizontal can only really have large regions that go downward specifically just from the asymmetry with horizontal. So we can see then that there are only 3 possibilities for 2. One of them is this, that breaks the 1 clue. One of them is this, which also breaks this 1 clue. The last one is this, which we now know must be accurate because we've seen the other 2 break. So we can mark in all of these as well, and okay. We can see for this 2 that their 2 must be right there, marking both their neighbors, finish off this 2, thus the 3 must go down there. We can finish off that, and alright. Now we can see that we have 1, 2, 3, 4, 5, 6, 7 cells left, and 6 mines left. We also know that by horizontal there can only be at most 1 mine in this region, so we can mark everything else as a mine, right? And then we know from our 1 clue here, there can't be a mine there. That finishes off the puzzle. There we go. Alright. So now I guess maybe I'll do 1 or 2 more. I'm trying to think if there are any of these I haven't done in a while. Yeah, I haven't done negation in a bit, so go ahead and do that. And if you don't recall what negation is, you should just watch the video for it to get yourself back up to speed. But here we go. Okay. So first we're going to consider the case for this 2 clue where these were the only 2 mines filled in, filling in the 2 requirement with just the black mines, right? You can see that this actually breaks the puzzle immediately because the 0 clue can no longer be bounced back, it can only be at most a 1. So then we know that we will not have both of the 2 clues filled in. If we have 1 2 clue, then that implies that we need all 3 of these filled in, or 1 black clue rather, 1 black cell. We know that all 3 of these must be filled in, which causes problems by horizontal, so that actually just tells us that neither of the black cells can be filled in. There we are. Okay. Next, I think I will just look through some of the cases involving the mines around this 2, right? So first of all, in this case, we then know there cannot be a mine up there, with the reason being if there were, then there's no way to bounce it back down to 2. Next, in this case, I don't know if we really get a lot from it. Not necessarily. Although, actually, I guess we can see that in both of these cases, neither of these mines can be, or rather, neither of these cells can have mines, because if they do, then there aren't enough left anymore to balance it back down. Like, for example, in yellow, you can see we don't have enough to put it back to 2, just because this one would have to be not filled in. Same thing kind of applies to red, so we can just mark both of those. And I think that also works up here, if I'm correct, right? Because we mark in that, yes, then yeah, we can only get down to 2. So we can actually also mark both of these. And lastly, we can see that in blue, which is just going to be both of these. Similar results are going to be happening up here, and this one down here cannot be a mine for just the same kind of reason. Okay. Cool. One other thing we can notice in the yellow case, if this one here were a mine, then that actually breaks the 0 because it no longer has enough to balance, so we know this one cannot be a mine in that case. We actually see the same thing with this one as well in both the yellow and blue cases, just because it unbalances the 0 in a way that isn't really resolvable. Alright. I'm trying to see if like the red case has a way to rule this out. Not for one of them, but it does for both of them. Looks like. Yeah, like, we can never have a situation where both of these are filled in, but unfortunately we can where just one of them is. Right? Yeah. Okay. Well, I guess actually, if in the blue and the yellow cases, both of these cells cannot be mines, then, yeah, we've actually also finished off all of those and all of those. Just because if either of them were filled in, the 2 clue would be unbalanced, so we can mark in all of these. There we are. We'll just go and get rid of these marks and kind of see where this leads us. So first of all, we can see that in the red, or rather, I guess in, yeah. We can see regardless of which case it is, right? Like, this cell just can't be a mine. Correct. Because then in blue case, we know this one needs to be 1, so we can mark that in. And lastly, in red case, if this one were a mine, then this can't be a mine, which would then give us that the 2 clue cannot be bounced back. So that one's just never a mine right there. Cool. That also tells us now for the blue case that we're kind of at a point where either it's going to be both of these or both of these. I don't think we can get anything from that immediately, but that's just something that's good to note. We can also actually see that the yellow case is impossible from this 2 up here because it just doesn't leave it enough room to really work. So that tells us that that one must be a mine. We can get rid of all of our yellow stuff real quick. Yeah. This is one of the unfortunate parts of this scheme for noting stuff, is erasing it is a bit of a pain sometimes, but that's okay. We'll make this look a little bit better. Okay. Now we can see that in the blue case, there must be a mine up here and a mine over here, just to finish off both of the 2 clues kind of in that area. That also gives us there's a mine over here to finish off the 0 clue. No mine there. And then from what we kind of talked about earlier, we know that this must be the case for the 2 clue. Alternatively, in the red case, we know there'll be 1 mine over here, and we also then know that there must be a way of, like, I guess 1 over here, which would just have to be this mine. So we know that that one's a mine, and this one over here is not a mine. There we are. Okay. So I guess now it also tells us in the red case, if this one were a mine, then we would have to make this one mine as well to balance out the 0, but that's not allowed through horizontal. So we just know that this one here is never a mine. There we are. It also now tells us in the red case, that one must be a mine to finish off this 2. And, okay. That means that in the red case, this one can never be a mine. If it were, then it would result in the 2 being unbalanced. And we also now know that, well, no, not necessarily. Never mind. Well, I guess, yeah, we can consider what happens if there are mines in some other positions, maybe, on the red case. I'm not sure. It seems like there might be more information we can glean. Actually, something we can see is that the red case is the only valid one now. I didn't notice this at first, but the blue case breaks this 1 through its definition. So we know that this one must be a mine. This one up here can't be a mine. That one must also be a mine. There we are. And we also know this one cannot be a mine as well. Okay, cool. So now we can kind of rule out this one being a mine. If it were, then both of these must be mines to satisfy the 2. Then we get this one's a non-mine, and that breaks this 1. It can't ever get pushed back down, so we know this one is not a mine. It also finishes off this 1 clue, finished off the 0 clue, and this 2 clue as well. Cool. Okay. And also this 2 clue. So now, it might be worthwhile to consider if this one's a mine, then we know this one's not a mine, but that breaks the 1. So there we are. Okay. And something that's kind of should be noted with negation especially is from the same kind of logic we talked about earlier, we can see that in order for these two clues to be balanced, and this is kind of also an argument based on the, like, I guess, parity of them, we know that either both of these must be mines, as this will just have a sum of 0, or neither of them are mines, correct? But we know both of them can't be mines by horizontal, so we can then mark neither of them as mines. Cool. Okay. The next thing we can consider is maybe, what to do with the remaining mines. Because we only have 4 left. We know that there can be at most 3 in this region, right? 1 in each part of the horizontal. But then that would put 1 over here, and that would break the 1 clues. So we know that both of these must be mines, right? And now then, that also tells us that given that there can only be at most 1 mine down here, if we put any mines in this kind of column, or rather row, that will break this 1 clue, right? Because it will either be 2 of the mines here or 0 of the mines there. So we know neither of these are mines. That tells us there's a mine over there, no mine over here. In order to finish off this 1, the last mine must be there. There we go. That completes the puzzle, and I don't think I'm going to do any more. Thank you so much for listening. Or I would assume watching. I don't know why you would listen to this on its own. It really doesn't provide a lot. But I will see you next time with our last, our second to last, special variant. Alright, peace.